We are going to discuss about the buffer capacity, right? So we all of you know that buffer is the one of this kind of solution which will resist the pH to change, right? So what is the tool or equation it may be which will tell us the what is the capacity of buffer and how it is going to work out, right? So let us try to understand buffer capacity. So the topic is buffer capacity, the amount of acid or base, right, that must be added to the buffer to produce a unit change of pH, right? To produce the unit change of pH. So what is the amount, what is the quantity it is required if it is acid buffer? So what is the quantity of acid is required to unit change of pH? Or if it is base buffer, what is the quantity of base it is required to produce a unit change of pH, right? So that is called the buffer capacity, right? Now what is buffer? So buffer is a solution which resists changes in pH when acid or alkali or base is added to it, right? Buffer is made for that reason, so that the pH will not going to change. That's what we are going to use this buffer into the different pharmaceutical formulation, right? Maybe in liquid dosage form, syrup, syrup, spirit and all those things, right? So that is the role of buffer. Now for example, I will explain you here, right? Suppose if any liquid formulation, if it is there, right, this liquid formulation pH it is 5, which is adjusted, right? So what will happen whenever you this particular formulation liquid sample upon storage, what is going to happen? We are going to open, like say for example cough syrup, we are going to open it, right? So whenever we open, it will come into the contact of air. There may be the moisture also into the environment. So in air they may get carbon dioxide, in water they may get in moisture they may get water content, and with carbon dioxide and water they will form the H2CO3, which is acid, right? So like that acid, if it is going to produce here, definitely the particular formulation is going to be acid, right? So when 1 ml of acid it is producing the pH 5, it is not changing. 2 ml it is not changing. Suppose if 5 ml of acid, if it is containing, or if it is adding into this particular liquid formulation which pH is 5, so if it is changing the pH, like it is going to acidic side 5 to 4 pH, means the 5 ml is the what you call buffer capacity. Up to 5 ml the buffer is going to maintain the pH, it is not going to interfere or it is not going to change, right? So that is called it's a buffer capacity. The particular buffer which we have added, it can tolerate that much of the acid whenever it will be produced by XYZ region, right? So that is the theme, right? When we talk about this equation, beta equal to delta B divided by delta pH, right? Where beta means buffer capacity, delta B means amount of acid and base it is required to change the pH of the particular solution, and the delta pH means change in pH, right? So that's what. So what this tool will help us to know the effectiveness of the buffer, means how much pH it is able to tolerate, or it is not allowing the produced base or produced acid to change its pH. It means formulation's pH, right? That's what it is called a buffer capacity. So each and every buffer will have their own capacity, that is called a buffer capacity. It's a tolerability. That's what. Thank you.